at 8.4. Dancing is over. Here we go, doing inverses. So when we did multiplying with inverses, for example, a times 1 over a, it was always 1. Now what does that mean for a matrix? If you take a matrix, call it A, B, C, D, then the inverse of A is 1 over the AD minus the BC times D, negative B, negative C, A. Notice the A and D switch places, and the B and C become negatives. So now, using a problem from your book, we're going to check if A and B are inverses. We're going to use problem number 3, which says A negative 4, 0, 1, 3, and B is 1, 1, 1, 2. To check, we need to know if B times A is equal to the identity and AB is the identity. So the identity matrix for a 2 by 2 is 1, 0, 0, 1. For anything bigger than that, you want 1s on the diagonal and 0s pretty much everywhere else. 0, 0, 0, etc. So multiplying our matrices, starting with the A times B, we're going to get first row times first column, which is negative 4 plus 0. For our second spot, we'll have negative 4 again, plus 0. Second row, first column, 1 plus 3, and 1 plus 6. So this is not an inverse because I do not have the 1, 0, 0, 1. Okay, now let's check to see if negative 1, negative 2, 3, 4 being our A, and our B being 2, 1, negative 3 halves, negative 1 half. Let's see if these are inverses. So AB would give me the first row, first column, negative 2 plus 3. My first row, second column is negative 1 plus 1. Second row, first column gives me 6 plus a negative 6. Second row, second column, 3 plus negative 2. Simplified gives me 1, 0, 0, 1. Okay, check. Let's check BA. So that's when we take 2, 1, negative 3 halves, negative 1 half, and multiply it by the negative 1, 2, 3, 4. So first row, first column, we get negative 2 plus the 3. First row, second column, we get negative 4 plus 4. Second row, first column, 3 halves plus negative 3 halves. And the second row, second column, 3 minus 2. Okay. So 1, 0, 0, 1 is the inverse. Check. These two are indeed inverses. So, what to do if it's not a 2 by 2? Well, to find an inverse for a bigger matrix, we need to augment it. So, let's find the inverse for problem number 21 in your book, which is the matrix 1, 2, -1, -2, 0, 1, 1, -1, 0. Again, 21. What we do is we take this matrix, then we put a line, and next to it we write what we want, which is the inverse, putting ones on our diagonal. Now we're going to do various row operations, like our system of equations, making the other side look like this one. Okay, so we've already got the 1 where we want it. That's good. Now we need a 0 here. So how we're going to do that, I'm going to do row 2 plus 2 row 1s, making my new row 2. So we're going to keep our original first row. We're not doing anything to that right now. And our third row. Now row 2 minus 2 of my row 1s, or plus 2, is 0. 0 plus 2 2s is 4. 1 plus 2 negative 1s is -1. Then we have the 0 plus 2 1s is 2. 1 plus 2 of my zeros is 1. 0 plus 2 zeros is 0. Now I've got a 0 needs to go here. So row 3 minus row 1 for my new row 3. And it looks like, while I'm at it, I might want to do row 3 divided by 4 so that I can get a 1. Leaving my first row alone. So subtracting 0, -3, 1, 1, 0, 1. Now I'm looking at this and I'm seeing that that will actually make that a 1 better, so I'm going to ignore this. We're going to do row 3 plus our row 2 for a new row 2. So 0, 4 and -3 is 1, -1 and 1 is 0, 2 and 1 is 3, oh, -1, 1 and 1 is 0, 0, 1, 1. I rewrite my top row. And looking, I see that my second row is exactly what I want it to be. So I am done with row 2. Now I want these other 2 spots to be zeros. So how we're going to do that is we're going to make this into a 0 so that I have 0, 0 and a 0 here. Row 1 plus row 3 for my new row 1. When I add those, I get 1, -1, 0. Then the 1 and -1 is 0. 0 and 0 is 0. 0 and 1 is 1. My second row is still good. 1, 1, 1. And I'm going to rewrite the third row because I haven't done anything to it yet. Now, to finish, I'm going to take this, because it's all the right things I want. I really only need to deal with a second column, meaning row 2 is going to help me out. So row 1 plus row 2 should give me my row 1. Row 3 plus 3 of my row 2's will make row 3. So I'll have 1, move that up. 1 plus 0 is 1, 0, 0, 1, 1, 2, 0, 1, 0, 1, 1, 1, and now row 3, 0, 0, 1. Add these and these, we get 2, 3, and 4. So this is now the inverse, because the other side is the identity. So my matrix 1, 1, 2, 1, 1, 1, 2, 3, 4 is our inverse. Let's try one more with a 2 by 2 from your book, problem number 13, which says 2, 3, negative 1, 2. Again, to find the inverse for a 2 by 2, we do 1 over the AD 4 minus the BC, which is negative 3, times, swapping the AD stays 2, 2. Then the opposite of B and C, so the 1 and the negative 3. So I have 1/7 times 2, negative 3, 1, 2. When you multiply a scalar, you just multiply every digit by that. So we get 2/7, negative 3/7, 1/7, and 2/7. So this matrix is the inverse for my 2 by 2. And we could check by multiplying. And just so you can see, one of your problems in your book, again, if we had 4, negative 7, 2, negative 3, multiplied by xy, equaling another matrix, negative 3, 1, what does this mean? Well, we can multiply these two matrices, same as we did before, row times a column. We'll get 4x minus 7y. My second row times my first column is 2x minus 3y. And because they have to equal this corresponding spots, this one's equal to negative 3 and 1. So once again, we have a system of equations, which we'll solve again next time.
We'll see you all real soon!